particle model of matter. Required practical, determine density, the core concept. Measuring the density of both regular shapes and irregular shapes using a displacement Eureka can. Example question. Describe a method a student could use to determine the density of an irregularly shaped small stone object. Student lesson breakdown. Step 1. Mass. Measure the mass of the irregular object using a digital balance. Ensure the balance is zeroed first. Step 2. Volume displacement method. Fill a Eureka can displacement can used with water until it is level with the bottom of the spout. Place an empty measuring cylinder directly under the spout. Gently lower the irregular object into the Eureka can using a piece of string to prevent splashing. The object will displace its own volume of water, which flows out of the spout into the measuring cylinder. Measure the volume of the displaced water at eye level from the bottom of the meniscus. Step 3. Calculation. Use the equation density equals mass over volume. Changes of state and heating curves. The core concept. Explaining internal energy changes and why temperature remains constant during a change of state. Example question. Explain what happens to the energy stores, temperature and arrangement of particles as a block of ice is heated from a solid at 10 degrees until it turns into a liquid at 20 degrees. Student lesson breakdown. Heating the solid below 0 degrees. The thermal energy input increases the kinetic energy of the water particles. The particles vibrate faster and the temperature rises. Melting at 0 degrees. The temperature remains constant even though thermal energy is still being added. The energy input is being used to break the intermolecular bonds, holding the particles in a fixed solid lattice structure rather than raising the temperature. This is a latent heat of infusion. The potential energy store of the particles increases while the kinetic energy store stays the same. Heating the liquid above 0 degrees. Once completely melted, further energy input increases the kinetic energy of the liquid particles again, causing the temperature to rise above 20. The particles can now slide over each other.